So we're now at our final panel of the day, which is the one that was actually most requested by folks. So I'm going to invite Paul at Illumitex, George at Lumigro, Chris at Heliospectra, and our moderator Marc to come join us.
Yeah, well, there's one slide too for all the stats. I'm sorry. Stats percentage. On your flash drive? No, he has All right, welcome. I think as was shared, this is certainly the finale in terms of exciting 2 days. We think about indoor ag, we think about moving indoors and growing. Obviously, lighting is a key component, and we're lucky to have a great panel of different backgrounds and experiences. And so we're going to have them give a little bit of intro, a little bit of overview of their companies. We're going to do a little bit of Q&A. We have got some questions that we've queued up for the different people, and then we're going to open it up to the audience as well for a Q&A standpoint. All right? So first, just would like to introduce Chris. He's with Heliospectra.
Yeah, so my name is Chris Steele. I'm the COO with Heliospectra. Here's my 3-minute rundown of our company. We're based in Gothenburg, Sweden. Our specialty is intelligent lighting for horticulture and plant sciences. The founding vision behind the company was to create a plant-controlled lighting system. So through using intelligent lights, programmability, remote monitoring and control, coupled with sensors above the plants, at the plant level, so that the plant is effectively telling the light what spectrum and light quality it wants. Along the way, we developed our own light fixture to do the research, since nothing like what we needed existed on the market. And where was I at? Yeah, nothing like it existed on the market. Other researchers saw it. They liked it. So we commercialized the fixture itself prior to having this full biofeedback system. So in 2013, we launched that research-based system. It's definitely more of a scientific instrument than a grow light per se. But since launching that, what our goal was to bring all of that sophisticated technology from a research lamp and bring it down to the commercial horticulture sector. So I'm seeing several people that I actually had a chance to talk with at our booth, and unfortunately I had to tear it down, but we had our new fixture over there. And so if anybody's interested in learning more about that, you're welcome to stop me afterwards. Yeah, that's Helio Spectra in a nutshell.
Okay, I'd like to introduce Paul with Illumitech.
Hello, everyone. Thanks for having us here. My name is Paul Gray. I'm the Director of Horticulture Lighting Sales, and I'm also the Senior Horticulture Scientist at Illumitech. We are an Austin, Texas-based company. We have developed what is our patented optic and LED array. What it brings to the market that's on the production side and then obviously on the research and development side is a lighting source that delivers a very high PPFD, meaning a photosynthetic photon flux density, in other words, a delivery of light in a uniform manner on the light intensity level and on the spectrum, because those are obviously two very key components for having a consistent and increased, say, production value. So that's something that we've focused on for several years now. We implement this technology through a series of different fixtures that are focused on the R&D side, production. It's also focused beyond, say, just production and looking at photomorphogenic responses from plants. So that is really what our technology has brought to the market. And you can see, I think, on the picture, we're obviously in various vertical farms. It's also on the research and development side, growth chambers. We also have various types of flower control in terms of timing your crop to market. So it's a technology that is very covers a large span of various horticulture applications, and so it's been a very exciting time for us. There's a market, whether it's in the food or other, say, horticulture markets that are emerging and that are kind of exploding onto the scene. And so when you can see a difference from an R&D side to taking it to a production level, it's a very exciting time.
Thank you. Now we'll move on to George. Just 1 second.
Oh, sure.
Okay, do it from
I can do it from here.
there. Yeah, why don't you come up?
All right. Hi, everybody. My name is George Chan. I'm the Senior Marketing Manager for LumaGrow. And just to see, just raise your hands if you've heard of LumaGrow. Just curious to know how well I'm doing my job. Okay, I'm not going to tell my boss how many hands were up, but that was reasonable. Right, so LumaGrow is a horticultural lighting company, right? We've been around for 7 years. And we're based out of Nevada. We were founded in 2007, and our whole goal was to bring high-performance, energy-efficient lighting solutions to the horticultural industry. So the whole industry as a whole ranges the gamut from, on one side, the hobby grower to the research scientists. So we're serving quite a few different markets. So yeah, we're based in Nevada, California. We have over 3,000 commercial installations in 32 countries, and we have on-site R&D, and we're working with major ag universities to understand the possibilities, but also to prove the viability of the product. And we're happy to say 7 years in, we're ecstatic about where we're at in the market. Now, this is a greenhouse grower survey. They essentially asked growers, like, what was your biggest pain point in running a commercial greenhouse operation? And the majority of people responded saying energy is a big issue, a big concern. Right behind that, they got pots and trays and other media as other pricing concerns. But this ranks it according to the size of the grower. So I want to talk about some of the installations we got just to show you the breadth. So on the sort of low light side, in high bay LED lighting, this is for propagation. That's Matthew Van de Sande, he's son of Theo Van de Sande. This is up in British Columbia, Chilliwack. So our lighting works really well in high bay and low light propagation centers. Now this is more pertinent for this audience. This is an aquaponics setup, a commercial greenhouse, I think in Wisconsin, called Clean Fresh Food. It's an aquaponics system, supplemental lighting. They've got their lights hanging to help sort of supplement the winter period and boost their use. I think they saw a 40% increase in their yields. And here, this is all indoor. This is sole source lighting. This is in Washington by Chris Bedrook of Urban Harvest. He was paired up with a charity up there to do jobs training, to teach people how to grow food indoors and also sell that food for the Millionaire Charity Club. Great project. We feel good about that one. And then last of all, this is GrowCo in Colorado, and just to show that our lights can provide enough power and intensity to grow high light level requirement plants like cannabis or tomatoes for that matter. This is sole source installation in a growth house in Colorado. And that's just a quick overview snapshot of LumaGrow, and if I wouldn't be a marketing manager if I didn't ask you to go check us out on social media. So thank you.
That's great, George. You may as well just, if you don't mind, just continue and kind of give us a little overview in terms of where you think the lighting industry, what's been happening in the lighting industry.
Yeah, it's actually really exciting. I mean, someone was joking earlier about the space and the LED space and how people see the opportunity in it. And I think the thought leaders and the folks, my colleagues here on the panel, sort of are doing our best to provide a solution that can meet the needs of growers while providing an energy efficient, doing it in an energy efficient manner. I think the existing and traditional technologies present some challenges. You know, you could imagine I was thinking about this. I came up with this last night. You imagine there's three hunters are going out, and one guy's got a shotgun, one guy's got a rifle, another guy's got a laser, and the guy with the shotgun sees a deer and takes out the deer. Another deer comes out. The guy with the rifle tries to place a shot, takes the deer down. And then the other guy with the laser beam comes in, and he shoots the laser, and he cauterizes the wound and saves the deer's life. There's this sort of idea that of photons that I think with LED lighting, the specificity of the spectrum and the efficiency of creating a spectrum that only provides the light that plants need is great. It's huge, I think, for the industry. The high pressure sodium, the metal halide folks, they've had the majority of the market share, and they still do. But increasingly, we're seeing these manufacturers investigating and looking into LED technologies because they know that is the way of the future. Well, it's not really the way of the future, as you obviously see here. The technology is here, and it's definitely ready. And people are using it, and the folks that do are quite happy with it.
Mm-hmm. Paul, are you saying some similar things?
Yeah, I think kind of for the reason that we're here and being at an indoor agricultural conference, I think one of the primary themes is control. How do we maximize our production through control? And I think with previous lighting technology, there is a certain level, but where it's taken to the next level is through LEDs. That's done on, just on a straight up, energy basis, but then also how that lighting can be applied. That's something that I think provides a much more, open future for agriculture, through the lighting application is through the control aspect. And so the technology that is inherent in LEDs in terms of how we apply specific wavelengths like George spoke to is where we can maximize the system through the lighting treatment. So I think that's where we're seeing this market transition over to LEDs because that is being realized.
Mm-hmm. Yeah, George just mentioned and highlighted a little bit about market share, and I think we'd be remiss in talking about indoor ag without also talking about other lighting options. And so, Chris, maybe you want to give a little bit overview in terms of what else is out there, what are some of the options and some of the market shares there?
Sure. So I was digging heavily into statistics and different research reports today, trying to come up with something solid. But I think George hit it on the head, and if you're out just walking through a greenhouse, you'll see it. I mean, sodium and metal halides still dominate the market, to the tune of 67%, is what it's projected to continue to have by 2018. I would like to see that change, and I think companies like ours and growers like yourselves have the possibility to improve that number for LEDs. What I'm seeing, I mean, the amount of inquiries that we get is, I mean, I don't know about you guys, but it's a lot. And the growers that are actually taking the risk, the punt, they're the innovators, they're the early adopters, and they're the ones winning. They're going to be ahead of the curve. So I mean, it's talking about having sodium or metal halide. They're going to be there. They are efficient lights, well, sodium. They do work. LED does have a little ways to go in terms of taking over market share, but
Are there certain
I don't know if you
applications
guys
that
wanna-
maybe you see LEDs maybe gaining some ground in and have better
Actually, yeah,
applications?
good point. Vertical farming. I think I see. I mean, Paul, you might be able to speak better to this than myself. I mean, we actually really just have a top light replacement. We don't have the bar style lighting at the moment. But that really seems to be where I see, especially from fluorescent technology, LEDs replacing that, and people having less of an issue doing so. I don't know.
Right.
That would be.
I mean, I think that in terms of market share and kind of where LEDs fit into it in comparison to, say, HID lighting, it's going to there's going to be differences in, say, percentages based upon the market. In other words, whether it's the greenhouse market, vertical farm, growth chamber sector. I mean, if you look at it on, say, a greenhouse side, there's an unbelievable amount of fixtures that are HID lighting that are ready to be replaced with LEDs, one just on an energy basis. When we look at it past that, then is it a function of a specific response or a specific result that we want to pull out of that greenhouse by changing the lighting from HID to LED? So I think that's where, when we look at where LEDs can go, I think it's something that it's a number that is probably astronomical in terms of the market that's available to be changed over to LED. There's an unbelievable amount of HID lighting out there, and there's many ways in which LEDs can replace that, not just on an energy savings basis.
What are some responses you've been seeing from the traditional options? George, maybe you can comment.
Responses in what regard?
Well, just in terms of highlighting perhaps their efficiency and why you shouldn't be changing to LEDs. Again, we're just trying to have a balanced presentation, if you will, about some options and
Sure.
what might be some considerations.
Yeah, I think with HID lighting, I think there's a comfort zone there, there's an understanding, there's a body of knowledge around how a grower can use a certain lighting system. And high pressure sodium and metal halide lights have been around for a long time, as have fluorescents. So when there's a new technology that comes into play, there's a large curve of educating the market, educating growers, researchers, and scientists, and that's a challenge for all of us in any new technology. The high pressure sodium and metal halide manufacturers, I think, have a commodity, right? And it's happening in the LED space too. The LED lighting market's going to be commodified as well. You can see how every day I get 3 or 4 emails from someone overseas in Shenzhen about an OEM product that they want us to license and market for them. That said, there are a couple other lighting technologies that are in the market too that a grower could evaluate: induction lighting, plasma lighting. I obviously as I work for an LED lighting company. I feel like LEDs are really actually a pretty, when you look at the big picture in general, when you factor in economy, energy efficiency, effectiveness, I feel like it kind of edges out the other technologies.
Mm-hmm. You want to elaborate a little bit more, or Paul?
And I think that's absolutely, I agree with George, and I think where where we have to then also look at some other aspects where maybe LEDs aren't the best fit, and I'm not afraid to say that, is that then it's based upon a geometry of the project, with a set, say, series of goals of what need to be reached. So, for example, if there's a area that is just this wide span of grow area, because of the throw that is provided by, say, HPS or metal halide, sometimes that is then the best fit at that point. Although, when the questions can be asked, and if there's a kind of brainstorming or if a discussion can be had on how we might alter that, say, geometry of that, say, grow area, that's then where, maybe for that situation, then maybe LEDs could be at play at that point. But it's always going to be on some level, like I think we've probably heard this time and time again at this conference, it's on a case-by-case basis. So I think that is one aspect to kind of keep in mind when looking at different lighting solutions, is how does the geometry play into that? And so I think that's a very key feature to kind of think about when we're looking at the different lighting technologies.
Mm-hmm. George, you were talking a little bit about the cost. We think about the economics. Talk a little bit about the LEDs and how people should be thinking about first cost, total cost of operation. And
Oh, sure. I think everyone probably here has some certain assumptions around the first cost basis, and in most cases, LEDs are more expensive. Capital expenditure is really difficult to address that issue. We have, I think, coming up with financing programs and other energy efficiency rebate programs, incentives to bring the price down definitely helps. So initial operating or capital expenditure for most of our proposals these days that are going out for our products, it's like 1 to 3 years, which is totally doable. I think if you showed that to a CFO, he'd say, let's do it. That said, if you look at but it is a challenge of financing, and how you secure that financing. You have to be kind of clever and know the right folks and jump through some bureaucratic hoops, sure, but the money's out there. And I'll also say, like the REAP program, we've qualified for a couple of those USDA REAP loans, and that due date I think is the second week of July. I'm not sure, but if there are growers interested in getting grants to supplement the purchase of LED lighting, they can apply for a REAP grant. That project would qualify.
just to build, we heard yesterday, if you want information about that program, grants.gov.
Yeah, right.
That's clearly the source for that. You mentioned the rebates too. So what would be a good source for the audience in terms of trying to identify maybe some of those opportunities?
Yeah, well, your utility is the first place to go. The second place to go would be maybe to talk to an ESCO, an energy service company. They often understand the rigors and the methods of reaching the utilities. If your account executive at your utility company doesn't get it, we often help and sort of facilitate the conversation between a utility rep and the customer. But the money's out there. Lights need to meet a certain level of qualification, certain levels of standard, because I think in the industry, when we were talking about general illumination, when those rebates came down, a lot of people got burned because the LM80 and the lifespan of these LED bulbs didn't live up to the expectations. So the utilities were accountable for giving out all this money. So you definitely want to make sure fixtures meet a certain criteria.
Mm-hmm. You guys have highlighted the need for education. So when we think about the industry overall, and lumens, watts, par, micromoles, daily light integral, how do we develop a common language here? So, Paul?
Yeah, I think one of the things that we kind of always want to kind of set straight in terms of when we're looking at how we define, say, lighting for horticulture applications is we want to try to stay away from the lumens kind of talk in terms of measuring light intensity because it does not really represent a true, value for par or the intensity of light that's offered through various horticulture lighting fixtures. So when we look at par, meaning the photosynthetic active radiation, that's the wavelengths between 400 and 700 nanometers. The way in which we measure that, say from a fixture standpoint, is we have the photosynthetic photon flux measurement, which is micromoles per second. That's talking about those photons of light that are emitted from the fixture. The second aspect that's very important to understand is the photosynthetic photon flux density. That is then a measurement of those photons hitting over a particular area. So that's the micromoles per meter squared per second. That's a very important that's a very important unit to understand, because that's where you're taking your measurements and understanding what light intensity you're receiving at the plant canopy, because that is what's driving your growth, driving the results that you're seeking, per the lighting treatment. Then past that, then we look at, say, the daily light integral, which is then a measurement of that, say, area of the photons hitting, say, over a certain, say, photo period. So then we're looking at moles per meter squared per day. Those aspects are very important when looking at choosing a lighting provider, because those are the aspects where you can start comparing apples to apples, with the emphasis on the PPFD, because that's your plant canopy in terms of where your growth is happening. So having a definition of those terms and using that to kind of go forward is a great tool to make sure that you stay on the right track for meeting your needs through the lighting.
Yep.
If I may just ask, how many people have heard those terms before? Okay,
Good.
that's great.
Good. But still, with that said, I would say, and I would even challenge you guys on all of your spec sheets, it's not easy to find that common language. And so I think as an industry overall, it's what can we do to sort of advance and help improve the communication there?
To that point, not to plug another event, but I'm not even going to it, but at the ASHS in Florida, maybe July, I think it is July. So there's going to be a roundtable discussion about developing this common language. And they're not only wanting just lighting companies, but also growers themselves at this discussion so that we all really can get there. Also, certification agencies have been in contact, I think, with all of us. So it's developing, but we need more than just lighting companies involved in that discussion, because it's very user-driven as well.
End user, right?
Yeah.
Yeah. You just mentioned certifications, and thinking about the audience, what certifications, how important are they, and what should people be looking for?
Sure. These are electronic equipment. Ours are basically a computer with lights. CE certifications, UL certification, or some UL equivalent, I would say, is the bare minimum. I guess on some level it's just hygiene for you as the buyer to know that you're getting a product that's actually been tested by a third-party qualified lab, seal of approval. The other side there is insurance purposes. Your installers, oftentimes they won't touch a product that's not UL certified. So I think we all probably manage that, but if you're looking at any sort of option, have those hygiene covered.
Yeah, I think it's great to highlight the other considerations, the installation and insurance as part of the equation, just so that people appreciate that. What about waterproofing of the fixture? Paul, do you have some thoughts there?
Right. So there's a whole kind of scale in terms of how we rate that, and that's through an IP rating. It's the ingress protection. So you have a whole scale. Say you might start at, say, 61 to 68, where IP 61 rating might mean that it's you can operate it out in the rain. And then there's a whole different level up to, say, 68, where you can then submerge the fixture underwater if you so desired. I can say there's a whole range of different IP ratings. I know for several of the people at this table, there's, one is like an IP 66, which is where it's a kind of high pressure, dust-proof fixture where you can have any type of foliar spray, any type of wash down, whatever it may be, applied to the fixture without any type of damage or even concern of it changing the operating. So, for example, in a vertical system where you're having obviously multiple layers of water, above or around the fixture, that's a very important aspect in terms of having a safe operating environment for your labor and for your operation. So, and that also ties into then the longevity of the fixture, because if you have those higher ratings, then they're going to be able to withstand those elements for a longer period of time.
Mm-hmm. When we think about the maintenance and say that choice has been made on purchasing an LED, George, can you just highlight what's involved with the maintenance of these fixtures once you've installed them?
I think it sort of depends on the product because different LEDs are designed a little bit differently. For products that have fans in them, a moving part, you want to make sure the fans operating, and the lens can get dirty. You want to clean the lens off, but for the most part, it's pretty maintenance free. I mean, a lot of the fixtures, aside from keeping it clean and dusting it off, I think some of our fixtures have been running for like 3 years, and they just make sure that it's on. I know that PL Lighting has recommendations and a maintenance schedule to maintain an optimum reflectance in the reflectors, and I think they recommend cleaning the reflectors every 6 months, and because you could lose up to 10–20% of your light on the reflector if you don't keep it clean. For the most part, maintenance is pretty minimal.
Mm-hmm. Yeah, you're just talking a little bit about a time frame, and that's also one of the key characteristics when you look at the lighting and options there. So how many hours, will something last? And, what should the audience be thinking about in terms of something says 25,000 hours, 50,000 hours? How should we have confidence in those results, in those measurements?
So I'll say typically say you would have kind of an industry standard is you're looking at, say, a 50,000 hour mark for where you would be 70% of your output. That's going to somewhat change depending upon your operating environment in terms of temperature. So when you look at different LED systems, you're going to want to look at that aspect in terms of where you are at, say, that 50,000 hour mark. When you look at, say, degradation lines of other manufacturers, of other, say, fixture types, like, say, HID, they're going to have a different, say, curve in terms of when they reach their failure point. LEDs, where they're different, is they have this kind of gradual, degradation over time that doesn't just go to a failure point where then it just doesn't work. So you still are at an operating, say, value at that 50,000 hour mark, and to kind of keep that, kind of give some perspective is that if you ran that fixture, say, that LED fixture for 24 hours a day, 7 days a week, that's going to be right around 5.5 years before you get to that point. And there's ways in which we can look at changing the geometry of a project to kind of get you back up to that 100%. But it just kind of goes to, once again, the geometry and how we can kind of help mediate that. But then again, at the 5.5 year mark, there's going to be probably some technology that we kind of wouldn't have to necessarily have this discussion.
Mm-hmm. The next wave, right? Okay. George, maybe you want to comment on a little bit in terms of how important it is matching lights to plants and thinking about the stage of growth and that different applications there.
Yeah, I think that's really all about what you're what your objectives are, and what you're trying to grow. And when it comes to matching your plant to light, I think there's two positions, right? And I started off talking with kind of a gruesome metaphor. I apologize for that. But the idea that you need a light, a grower needs a light to grow plants, right? Bottom line, they want healthy, happy plants. And I think there are, in general spectrum, all of us could easily provide a good quality of light to grow happy plants. Simple. That said, on the other end of the spectrum, when you start getting, this is where it gets really exciting, right? I think you start talking about targeted spectrum and the specificity of each diode and the effects that it can have on the morphology of the plant, internode length, onset of flowering. This is where LED technology gets really juicy, right? And there's a lot of opportunity to explore this and to use it to your advantage. As an example, I think we've all found that you can use spectrum to grow basil to flavor. So if you want a spicy basil, and this is we just did a study in-house, and we grew the same kind of basil, and she did a taste test. We got to taste it. One was spicy, one was bitter, one was super sweet. I'm like, what did you do here? She said, I just changed the ratio of red and blue. And so a chef could conceivably say, I want to have a spicy basil because the way I cook, I need some kick in it, right? So growing plants to a chef's flavor profile, that's exciting, and I'll let you guys, maybe you guys can chime in too.
Yeah, I mean our systems. I'll talk about the research system. I mean we're looking at up to 10 different channels of control and different colored spectrum that you could put in there. And I think primarily most manufacturers on the commercial side use a 450, a 660 nanometer, and then maybe some white or green LED mixed in there. But if you as a grower are really wanting to dial in, you have the ability to specify certain wavelengths and conduct your own research, and then have somebody make, your plate. I mean, every cultivar of basil is going to react to different light differently. Same thing with salads. Some you can throw like any sort of light on it you want, and it's going to grow and grow fine. Others you can really tweak, and they're very plastic, and flavor profiles adjust and these sort of things. So I guess a bit of it's up to you as the grower, and who your end customer is. If it is a
Yep.
high-end chef that's looking to do something like that,
Yeah.
or if you just want to mass-produce good enough product.
Right, and then to add to both their points, I think, which is definitely on spot, is that you can look at it on the plant level. You choose a lighting regimen or a spectrum based upon what you want to draw out of that plant, whether it's straight up biomass production or some type of morphological change in terms of, say, changing the internodal length. That can be simply just a qualitative aspect that you're seeking as a commercial operation, or you take it to the research side where you're looking to use a dynamic spectrum type of application, which is going to allow you to come to those data points that you're seeking. But on a production level, that may not then be the best case scenario, because at that point, once you get to that point where you have a spectrum that you have dialed in, if you're on the production level, then all you care about is production at that point. So I think there's different, say, fixture types and different things that different companies will offer, where it may be a static spectrum that is set for a, say, specific purpose, maybe certain types of germination or flowering responses, or just biomass per watt accumulation, or a photomorphogenic response. So there's different ways in which you can choose your lighting application. I think that's one of the things that's most liberating about LEDs, is how they can change the market per your requirement.
Yeah, and I think it kind of changes the way you grow and configure your space. So as an example, cannabis growers, they have a bedroom and they have a flowering room, right? And then they spend a lot of time shuttling plants between the two spaces. And so there's man hours there. But with a controllable spectrum over time, over the duration of the crop, you start off so like low light level. You're getting these plants to root, the clones to root, and they start growing. You've got a vegetative spectrum to optimize that, and then as they start to grow, you might, depending on what you're doing, if it's what type of technique you're using, you could start to program that spectrum to sort of, in the same place, to just kind of change into the next phase of growth. And so over time, with these sort of programmable spectrum over time, you can have your set schedule, a light recipe, a light program programmed in, and just running. And it's, ideally it would be tied into your other environmental control systems. So the idea is we're trying to move into sort of a feedback, incorporate feedback loops. Gene Giacomelli is probably talking a little bit about that, and I think I've had conversations with folks about how that's a great opportunity for really becoming an even more sophisticated grower. And I think I'm really excited to see how growers are going to use the technology. I think we're going to find some really cool stuff coming out of it.
Great. I wanted to pose a scenario to each one of you and get your feedback on thinking about, if a grower out there was thinking about using a high-pressure sodium, 600 watts, maybe for growing leafy greens, what would you guys recommend individually?
I go first. So one of the things that I think I've kind of mentioned before is we look at the geometry of the project. So first off, what is that area that the plants are being grown on? So let's say it's a 4x4, say, tray. You would want to then look at what your PPFD, in other words, what's your light intensity at the plant canopy. Look at all the other parameters, say your temperature, relative humidity, your CO2 levels in terms of what you're growing, and how we can maximize that space in terms of what you've had before, say with a 600-watt HPS system or metal halide or just HID, and how we can take the next step from there. Typically, an easy, say, general setup is that we can, right off the bat, typically, I think everybody at this table would say, is that we can cut the energy in half. That's kind of typical with LEDs. But there's ways in which when you look at all those factors and how you can kind of provide a system that can really hone in on your production, it goes back to, you know, how we can then apply the lighting per those say requirements or that geometry of the project. I think that's really where it lies.
Yeah, I would add, I think that's right on. Sort of, you sort of get the parameters of the growth environment. Is it and ask, is it supplemental? Is it sole source? So you understand those parameters, environmental parameters, and then what we typically do then is we start running. We do some light planning with light planning software to understand the proper coverage to meet the intensity that the plant needs. And it's important to realize too, you know, when you design a system, you don't always get it right? So there's a period of calibration, of fine-tuning it. So you want to allow, you know, we typically allow for a little bit of time and set expectations up front that, like, okay, we're going to have a grower consultant call you, talk to you, and see how it's going, right? So you know, it's nice with a new technology. It's good to sort of kind of walk people through it and dial it in.
Mm-hmm. Chris, anything?
Yeah, I think the only thing I would add to what they've said, because what they've said is right, is what your goal as a grower is to making the switch to LEDs. And that's a question I always ask, I mean, especially if you're doing some sort of retrofit. You know, why? What is it that's driving it? Is it that you heard you can save 50%? Is it that you want to grow a tastier basil? Or is it that you just heard it was the next best thing, so you want to try it out? I think that factors into this, and it factors into our ability to actually help you. I mean, to be candid, there's some instances where it's better for me to say no to you as the grower, that it's not worth it to use our lights. You know, you will be disappointed because of X, Y, and Z. Your goals don't match what this is going to do. That said, if they were different goals, or you are moving into this for the right reasons, by all means, it's well worth it, I think.
Mm-hmm. George had shared some sort of parameters on payback, 1 to 3 years. Are you guys seeing similar opportunities, Paul and Chris?
I think yes. I would say that where a lot of that depends is obviously the crop type that's being grown. The second part is kind of what those goals are. We see growers who their primary focus is energy savings because of what the cost in terms of kilowatt per hour does to their bottom line. So a ROI is solely focused on that. In other cases where it's all about production, because if you don't have that product on the shelf, then you're absolutely losing money. So that can then change that ROI drastically as well, based upon different margins of different crops. So we've seen the same type of response, you know, typically around 3, and you can drop it below a year. It just kind of depends upon the market and the crop type at that point.
Mm-hmm. And how should we think about performance? And that's intentionally open-ended to hear what you guys are thinking are some of the key sort of buttons there.
I would just say, I mean, you want to find a fixture that's, as what Paul was referring to earlier with the micromole per second, that has it's very good at converting electricity to photons. Because in the end, that's what you're paying for, are those photons onto your plants. So whether it's any of us or any of the others out there, I would be looking at that closely.
Mm-hmm. Just to be able to help the audience again in terms of resources and sources of information, in terms of the type of improvements you may get, whether it's yield, or whether it's number of days, those factors. Maybe you guys want to talk about, I know a number of you have different case studies, but maybe there's specific research papers that you guys might want to refer people to.
You know, there was that example that I showed of Clean Fresh Foods, and that was the case where they did not have lighting before, and when they added lighting, they got a 40% enhanced yield increase in their leafy greens. Rob O'Hara at Rainbow Greenhouses, he was using high pressure sodiums, I think 1,000 watt, hung maybe 6 meters up high. And what he said, he took a week off his propagation cycle, so that his cuttings were rooting faster. There's some other numbers. We have a lot of numbers on our website, and you can always call. But yeah, those are two numbers that I have. I think the cannabis growers, I don't have any data there. I would love to get data from them with regards to their yield. That's a fascinating industry, right? And if we get information from there, I think it sort of in a way kind of informs other crops as well, because they're secretive for a reason. It's a clandestine industry that's changing, and the sooner I can sort of talk to more of my customers and get data, I think the more we'll all benefit. And this applies to all growers.
Yeah, and I think you'll see the different types of performance, whether it be on kind of a ease of use in terms of how easy is it to implement the technology into your operation, then going back to then what your goals are. There's many different situations where based upon the crop or the market in terms of where you're growing, whether or not it's a qualitative response that you're looking for in terms of if that's your metric, or is it a quantitative aspect in terms of just overall production. Typically, it's the more I can produce, the better off I am. But that's where then what we've seen, we see ranges of production gains that range from 5 to 10 to 15 to 20, 30%, but you have to talk about what you're defining. I think that's a key part, because on the front end, you may not be able to put a quantitative value to, say, a qualitative response that you are drawing out of the plant per the lighting treatment, but it's then what happens in terms of what you're able to sell at that point. So I think there's lots of different ways to talk about performance. It's just defining what it is that you're seeking on the front end and how we can then help you reach that goal at that point.
Mm-hmm.
We also saw, and I think you guys have probably seen it, for flower growers, cut flower growers, there's a delayed senescence of the flowers. So we've got a study that's about to come out done by University of Guelph. They did a study with gerberas, and they did I learned about this first time. It's called the vase test, and it's just like cutting flower, put it in a vase in water, and seeing how long the flower lasts. And the research scientists, they were totally skeptical to begin with. They're like, "Oh, this is not going to work." Mike, yeah. So at the end of the test, we get a call, and the principal researcher is saying, "My postdoc wants to go to cultivate with you guys because he's so excited about the quality of the flower that you guys grew in the vase life." And when we heard that, we were like, "Yeah, right on. This is great news." So, and I think we're going to continue to discover a lot of these sort of benefits that changing the lighting spectrum will have on plant growth.
That's great. It's great to get an overview and hear about the latest developments and get your insights. We definitely wanted to save some time, though, for the audience as well, so we wanted to open up at this point to Q&A.
As we shop for lights, how do we choose? What are the differences that we find out there between the different companies? Because, again, I get 5 emails a day from different LED lighting manufacturers that there's all kinds of LED lights coming out of China, coming out of Europe. I mean, what's the quality differences, and how do we choose which is the best light for the application?
Heliospectra. Punkt slut, as they say in Swedish. No, I'm kidding.
Yeah.
These guys are getting pissed. No, again, look, I don't know who's emailing you 5 times a day. We get the email as well, probably from China. There's a lot of junk out there. I think it's a matter of looking at reputable companies, and there's others in the room as well to consider. Again, it goes back to how the product's been tested. Are there growers working with it that have actually seen positive results? Are the ROIs real, or is somebody just feeding you a line of shit? I mean, it's really digging into it. I mean, the industry's just gotten a black eye over the years. I mean, a lot of junk has been out there. A lot of bogus claims have been made, or maybe they were just adventurous claims that were made.
Hype.
So,
Yeah.
yeah.
The one thing I'd say is to first maybe look at defining what it is that you're seeking in terms of what are your goals for your operation. I think if you define that, then look at what the differences are between the different manufacturers. I think that first kind of gives you a starting point of how you might want to approach a certain type of lighting application. Is it, for example, is your geometry a 18-inch, 20-inch, say, distance from the top of the plant canopy to where you have available to mount your fixtures, or are you doing more of a supplemental lighting, say, in a greenhouse? That's within those differences between fixtures, or even the manufacturer comes into play of what might be the best solution for you. It's then having that conversation with the manufacturer in terms of what you've defined as your goals. That's then how you can kind of see what might be the best lighting application for your operation.
Yeah, I think it's kind of like asking, how do you buy a car, right? You do your due diligence, you identify what it is you want to achieve and what you need, and then you take it for a test drive, right? And so it's good to, if you can get a pilot going and test it out for a period of time and try to understand how it works, you'll know pretty quick whether or not it's right. And I think that's you need to get your hands on it.
That was a much better analogy.
Thanks.
Yeah,
Well, I'm
you
in the
really need to
process of
test it
buying
in your
it.
application is the key message there,
Yeah,
which is,
yeah, that's right.
yeah,
That's right. With anything new, you kind of want to understand how it's going to work for you before
Sure.
diving in.
yeah, please.
What are the technologies that will be able to adjust the quantity of lighting design? Maybe affect the lifespan?
So I can say, for example, on pretty much every fixture that we offer a dimming capability. Depending upon fixture type, we can go from, say, a 10% power level, obviously, to 100%. Other cases, we can do a soft off, which is at the 0% to 100%. That absolutely affects the LED lifetime, because then at that point, you're not running as much power through it. So I can say in certain, installations where we have implemented a type of dimming, say, regimen based upon crop type and the ways in which we're maximizing a system based upon the dimming, we can extend then that life out to a point where it may outlast the facility that they were installed in because of the capabilities at that point. And that can be on a very precise level too. I mean, so you can implement almost any type of control to do that. I mean, we use a 0 to 10 volt on dimming capability, so it's something that is very easy to implement. It's just whether or not the geometry or the definitions of the project call for it.
So Gene was there talking about growing extreme climates, and he's talking about lighting and talking about grams per kilowatt produced. I'm just curious, from your standpoint, either why aren't we using that as the benchmark, or why should we be using that?
I think that's irrelevant. I think depending on the crop, and again, what are you trying to do? I think that's a valid measurement. This goes back to the quantitative versus qualitative needs of what you're trying to do. If you're growing a cash crop that's based on weight, that makes sense. But if you're growing like a boutique crop that's based on flavor, that might not be appropriate, right? I think for those applications, he's trying to grow as much food as possible, right? And to that end, I think it would be really good to have more studies that show the efficacy of different spectrums of light and their ability to grow plants. But every plant is different, as we know, and it might have a totally different spectral requirement. So is there a way where we can listen to the plants, as Gene was saying, like hook up sensors to it so we understand what's the photosynthetic rate, if that's what you're measuring and you're going for? If we can create a quick feedback loop and have our spectrum sort of change in response to that, I think that will facilitate the analysis of optimizing, yield per watt per electricity unit.
You mentioned efficacy. How about efficiency? Is there something we should be thinking of there?
Meaning, in terms of efficiency, in terms of just the differences in terms of what you can save on energy?
Yep.
Yeah, I mean, it goes back to then, I think, if I'm understanding you, it goes back to then just the geometry project in terms of how we're going to maximize that. If you're looking at, say, particular installations where you are, if you're trying to maximize that energy savings, it goes back to the geometry of the project and what your goals are. Typically, it's anywhere from 50 to 60% energy savings, and that's also incorporating then the differences in, say, in your heat load as well. Because watts in or watts out, it's whether or not it comes out as a light output or heat. And so there's multiple energy savings at that point. Then it goes past, say, just the lighting aspect to then how you design your system if you're, say, designing a new installation versus a retrofit. So there's many ways in which you can increase that energy savings if it's new versus retrofit on that basis.
Right. Yeah, and I think that oftentimes when we start talking about efficiency and efficacy, I have to kind of clarify what the original question is. It's like, are you talking about what Paul was talking about, like what's total energy efficiency, the big picture energy efficiency savings? But there are other conversations around what's the efficiency of the conversion of light or of electricity to light. And that's another conversation. And I think that's kind of like a horsepower conversation. Like how many horsepower does it put? You can kind of, I think we are in danger as an industry of trying to seek the highest level of efficiency and getting kind of lost in the weeds without stepping back and looking at the design of the entire product and what we're trying to achieve to create a commercially viable product that consumers can afford and work into their system. Because obviously you can pick the highest efficiency LEDs and it might not be commercially viable. So it's important. It's a design challenge. It's also a balance. It's a fine dance when we sit down with our engineers and we try to understand what the market needs, what they can build, what's totally possible on the far end, and then finding that sweet spot that'll work, that's commercially viable.
I think that George's point, yes, you can seek the highest powered engine, say, you might find in a car, but if you don't have, say, the proper tires, it's not going to go anywhere, right? So I think another aspect or another metric to look at past, say, biomass per watt would be then a ppfd per watt. In other words, what is the cost for you to reach a, say, certain value of light intensity at the plant campus? That would be another very important metric to look at. Because if you're looking at, say, ppf per dollar, if that light that is being emitted from that fixture is not delivered to your plant canopy, then it's not doing anything for you. So that's probably another very important metric to look at in terms of what is the best lighting system for your operation.
That's great. Other questions? Please.
We do all of our manufacturing in Sweden.
So for us, we actually manufacture the LEDs ourselves because of our patented technologies. So we have a manufacturing site in Penang, Malaysia, for our LED arrays. And then the fixtures, a healthy portion of them we do build in Austin. And then for certain projects, we may use a contract manufacturer in China. But the majority of what we do now is in-house in Austin.
Yeah, LumaGrow, we manufacture them in Fremont, and sheet metal, I think, is bent up in Oregon or Seattle and shipped down. So yeah, we're US based. Some of the components are overseas, and we're trying to optimize and drop the bomb again, so that we can create a fixture that's priced that works well, but also is priced appropriately for the market.
Going back to the problems, what we found with solar is that in our case,
Like a solar lease, you're referring to solar lease? Yeah, we actually have a program where we set up that we can lease the lights, so you're leasing photons and you're not actually buying fixtures, you're leasing the light. And then when the lease is over, you give us back the fixtures and it kind of keeps it brings down the cost a bit, but initial cost, but long term you're paying a little extra. You pay a premium for it. It's an interesting model, and I think we're trying to see if it'll work. A handful of people have taken us up on it, so we're watching it closely and trying to support that. We'll see how the market responds to it. That I'm aware of? Yeah, I think so.
And we also offer leasing programs as well. So that's another
There are
option.
some other options.
Yeah.
You can go ahead and share. Yeah, so we're fortunate we have a wide range of audience members, so Phillips is well represented. Any other questions? One last question for the panel? All right. Well, thank you, everyone. Appreciate your attention.
Thank you, guys.
Thank you very much.
Thank you, Mark, and thanks to the panelists also. So we've got to the end of our conference for this year, and I would just like to finish up by thanking our speakers, sponsors, exhibitors, and staff. If anyone's going back downtown, the shuttle is waiting for you.